Okay, gonna go over the topic 2 main questions that we need to be looking at for reviewing for our our chapter 2 tests coming up. Okay, once again, this video will be accessible on the website in the video section, and also it'll be due in the black bin before the test on Friday. Once again, remember, this is designed to help us give us an idea of what we need to be studying. So obviously, first goal right now is to do this on your own, and then go back to the video and watch how we accomplish these problems. And those that you need to change or maybe study a little bit more on, you can. But if you do turn this in to the black bin on Friday, you will get the bonus points for them. So, with that being said, let's go ahead and jump into the problems here. First one, what is the slope of the line y is equal to negative 3 over 2x plus 4? Okay, now keep in mind, very basic, but we do need to understand that the slope, when our equation is written in y equals mx plus b form, is the number in front of the x value. Okay, so we do have a slope here of negative 3 over 2. Okay, want to make sure we're able to identify that. And if we were also asked to find the y-intercept, that is the number that is out by itself. So since it's a positive 4, our y-intercept would be 4. Okay. The next one here is what is the slope of the line containing the points 3, 3, and 5, 6. Okay. Now, once again, we're able to locate in an equation what the slope is, but now in this one, we're actually going to have to calculate the slope. Which, remind ourselves, that is the equation y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? So in our coordinate points over here, since this is the first point, we'll go ahead and let this be our x1, y1. Remember, you should always have an x, then y, and the number should be the same. So this is the first point. This is the second point. Okay? Because after that, if we plug in our information into our formula here, we should be able to calculate the answer. So y sub 2, which was a 6, minus the y sub 1, which is a 3, all over the x sub 2, which is a 5, minus the x sub 1, which is a 3. Okay? But always remember, the reason that the y's are going on top, slope is measured as rise over run. Rise is up and down on the y-axis, run is side to side on the x-axis. So we do the calculations here. 6 minus 3 is going to give us 3, and 5 minus 3 here is going to give us 2. So the slope of the line containing these 2 points would be 3 over 2. Up 3 units, down to the, up 3 units, 2 units to the right. Up 3 to the right 2. Up 3 to the right 2. Just like this one up here was a negative 3 over 2, that would be down 3 units to the right 2. Down 3 units to the right 2. Okay? On this one, what is the slope perpendicular to the line y is equal to 3 over 2x minus 4? Now, in order to calculate the perpendicular slope, we probably should identify what the slope is of the line here. And the slope is the number for the x, 3 over 2. Now, for perpendicular slope, remember the symbol for perpendicular is upside down capital T. Okay? Remember, for perpendicular slope, we want the opposite inverse. Now, what opposite is referring to is the sign in the front here. So this is a positive 3 over 2, okay? So since this is positive, the other one has to be negative, so we should have a negative sign out front. Okay, remember, they should always be opposites, one being positive, one being negative. Now, the inverse part is referring to the fraction. So since this is 3 over 2, the inverse of that, the flipped form of it, or the reciprocal, is 2 over 3. And that gives us our perpendicular slope right there, okay? And we can always check to make sure these are the perpendicular slopes, okay? Or this is the perpendicular slope to this one. All right, if we multiply these two together and simplify, we actually come out with the number -1, and all 2 lines that are indeed perpendicular will always come out to be -1 when you multiply their slopes together. All right, the next one here, this is kind of a two-parter. For the line y is equal to -6 over 7, x plus 4, state the slope of a line parallel, and also state the slope of the line perpendicular. So it's kind of like doing the previous problem over again, but also adding in us finding the parallel line. So just like before, let's go ahead and figure out what the slope of this equation is, which is the number in front of the x. So that would be -6 over 7. And let's go ahead and answer the first part. The first part was they wanted the slope parallel. And remember, that looks like an 11, but it's 2 vertical lines. The slope parallel, well, When it comes to parallel lines, their slopes have to be exactly the same because they have to be going up and down and left and right at the same rate. So if the slope of the line is negative 6 over 7, a parallel line to that one would also have to be negative 6 over 7. So that's one of our two answers here. Now the other one, they asked for a perpendicular to this one. And it's the same thing as before. Since this, we got to do opposite inverse for perpendicular. Since this is negative, this one's going to have to be positive because they got to be opposites. And then we look at the fraction and we do inverse of that. So where this is 6 over 7, this one's going to have to be 7 over 6. So parallel lines should have the exact same slope, which we see that here. Perpendicular lines should have opposite inverses, one negative, one positive, and the same fraction but flipped, inverted. It's reciprocal, however we think of it. All right, now the next one is wanting us to write what is the equation of a line perpendicular to this and passes through the point 2, 4. Now, in order to calculate, we have the point, now we need a slope for the perpendicular line. Now, this one is not written in slope-intercept form, so we do have to get rid of this times 3 right there, and we get rid of times 3 by dividing. We divide every little part by 3. Now, 3's on the left are going to cancel out, leaving us with y is equal to 6 divided by 3, which is 2x minus, and we're just going to go ahead and leave that as 4 over 3. Now, the slope of this line, number in front of the x, is 2. We are wanting to use the slope that is perpendicular. Okay, keyword there, perpendicular. Once again, opposite inverse. Now, this is positive, so the opposite would have to be negative. Now, the inverse might be hard to see here because it is just a whole number, but if we go ahead and put that as 2 over 1, we now see it'll be easier to do the inverse. So the inverse of 2 over 1 would be 1 over 2. Okay, 1 over 2. Now, we have our slope, and we have our point way over here. This is our x1, y1, to where all we need to do now is plug in what we know into our point-slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. Let's plug in what we know. Y minus the y sub 1, which is 4, equals the slope, which is negative 1 over 2, times the quantity x minus the x sub 1, which is 2. Okay, I'll zoom in here a little bit so we can see a little bit better. Now, we do need to get the y by itself, but we do have a number on the outside set of parentheses, so we should always be distributing our slope through the given set of parentheses first here, okay? Which that'll leave us with y minus 4 is equal to negative 1/2 times x. It's just negative 1/2 x. Then we have a negative times a negative, which is a positive, and then we have 1/2 of 2. So 1/2 times 2 just gives us 1. Then we got to get the y by itself, so we're going to have to get rid of a minus 4 by adding 4 to both sides. And I'm going to write my equation over there so it's a little bit easier to see. So those 4's are going to cancel out, leaving us with y is equal to negative 1/2 x. 1 plus 4 is positive 5. So this would be the equation of a line that is perpendicular to this original one, but also goes through the point 2, 4. All right, the next one here, write the equation in slope-intercept form. Remember, that's y equals mx plus b form. And if it helps us out, we're going to go ahead and just write that just as a reminder, y equals mx plus b form of a line with a slope of 2 and y-intercept of, okay? So I will address this when we hand these out on Thursday, but the copy machine kind of ran this one off. We want to go ahead and make that a 5. Okay, make that a 5 right there. All right? So once again, they give us the slope, okay, that is the m. They give us the y-intercept. This is the b. If we want to put it in y equals mx plus b form, we are simply just going to plug in our information. So we have y equals mx plus b form. We can never write down our equations enough to increase our memory. Let's plug in what we know. Y is equal to, all right, we had negative 2 for the slope, so negative 2x plus this y-intercept, 5. Okay, I want to make sure we're understanding that part right there. It's a little bit of an easier one, hopefully. All right, here's one that's a little more challenging. Write an equation in slope-intercept form. Just as a reminder, that's y equals mx plus b. Of the line containing the points 6, 2, and 8, 7. Now on this one, we have to do a couple things, because normally if we have a point and the slope, we can plug it in the point slope form and then solve for y. Problem is we don't know the slope just yet, so we actually are going to have to calculate that first. So this being our first point, we'll let this be x1 and y1. This being my second, let this be x2 and y2. Okay? So we're going to calculate the slope of that. I'm going to write this way over here. Once again, slope, remember, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right? So let's plug in what we know. The y sub 2 is 7 minus the y sub 1 is 2. All over my x sub 2, which is 8, minus my x sub 1, which is 6. Okay, so let's do those calculations here real quick. 7 minus 2 is 5, all over 8 minus 6, which is 2. And once again, that's my slope right there. And we want to use one of these 2 points. And it's probably easiest to go ahead and use the point that we already have labeled as x1, y1. Okay? Now, this is not saying we want the line perpendicular or parallel or anything, so we're just going to use this slope and that point. So we're going to plug these into y minus y sub 1 equals m times the quantity x minus x sub 1 to get our equation. So let's plug stuff in. All right, y minus my y sub 1, which is 2, equals my slope that we just found, 5 over 2 times the quantity x minus the x sub 1, which is 6. Okay? Now we do want to solve for y, but we want to go ahead and distribute our slope through our set of parentheses here. Okay? That's going to leave us with y minus 2 is equal to 5 over 2 times x, which is just 5 over 2x. Positive times a negative is a negative. Then I have 5 halves times 6. Now this can be written as 6 over 1 to help us out here for the fraction. So 5 times 6 on the top of the fraction will be 30. 2 times 1 on the bottom will be 2. So we have 30 over 2. Now we want to go ahead and simplify if we can. So 30 over 2 will simply is 30 divided by 2, which will give us 15. Now to get the y by itself here, we will have to add 2 to both sides. Okay? In which case the 2's cancel out on the left, leaving us with y is equal to 5 halves x minus 15 plus 2, which is a negative 15 plus 2, which is a negative 13. Okay? So that would be our equation written in y equals mx plus b form. Y-intercept, we plot a point at negative 13 on the y-axis and apply the slope 5 over 2. Up 5 units to the right 2. Up 5 units to the right 2. Okay? Got 5 more questions here. Let's take a look. Write the equation of the line we have here. Okay? Now, in order to write the equation, it will help us if we find out what the slope and the y-intercept is. Because remember, we're going to plug this into our y equals mx plus b form for our equation. So it'd be easiest to know that. Let's go ahead and take a look where b is. B is where it hits the y-axis, and it's hitting the y-axis right there at a 2. Now the slope. If I start here and see where the next place it intersects at, which the intersection actually right here on the x-axis at 1. Okay? So if I start here at my y-intercept, it went down 2 units to the right 1 unit. Down 2 units to the right 1 unit. And that would be a slope of negative 2, down 2, over 1 to the right 1. Now we can simply have just written that as negative 2, okay? Or we can leave it as a fraction. Now we need to plug in our information. Our final answer is going to be y is equal to our slope, negative 2 over 1, x plus the y-intercept of 2. That would be our equation for the given line. Now the next one here, they're wanting us to determine if these 2 lines are parallel to one another, perpendicular, or neither. Okay? Now what would help us out here is if both of these were solved in y equals mx plus b form. So the easy one for this is the y is almost by itself. We got to get rid of a times 2. We get rid of a times 2 by dividing everything by 2. Okay? Now the 2's on the left are going to cancel out, leaving us with y is equal to negative 5 over 2x. And then we have 4 divided by 2, which is 2. Now we're just focused on the slope when we're trying to determine parallel, perpendicular, or neither, and the slope of this one is negative 5 over 2. Okay? This equation requires a little bit more work because this is actually written almost in standard form. Now remember, standard form does have a couple other characteristics, but the basic thing we have to remember with standard form is that the x and the y are on one side and everything that doesn't have a variable is on the other. Now, we'll get into later on where we try to talk about, hey, the greatest common factor between all of these has to be 1, okay? Which we'll get into that, like I said, later on. But right now, we're focused on getting the y by itself. So we're going to get rid of a positive 10x by subtracting 10x from both sides. Okay, and I'm going to write that over here since I'm running really low on room. So I'm left with 4y is equal to, since those 10x's canceled out, negative 10x plus 16. And to get rid of a times 4, we are going to have to divide everything by 4. In which case, the 4's are going to be gone there, leaving us with a y is equal to negative 10 over 4 does simplify. Okay? Once again, we can always check that on a calculator real quick. If I do negative 10 divided by 4, yes, it's going to give me a decimal. If I want to get that to be a mixed number, if I hit second PRB, second probability, it changes it to negative 2 1/2. Now, negative 2 1/2 and this one don't kind of look like one another, so let's go ahead and change this to an improper fraction by hitting second ABC. And I'll change it to the negative 5 over 2. So the slope of this one is negative 5 over 2x, and then we have plus 16 divided by 4, which is simply 4. Now the slope of this one, I'm running very low on room here, so I'm going to have to write this way up here. Okay, the slope of this one, the number in front of the x, is negative 5 over 2, which probably does sound familiar because negative 5 over 2 was what we got the other slope to be. So we have two slopes that are exactly the same, and two slopes that are exactly the same are parallel lines. Okay, they're parallel lines. Next problem here, we have to find the x and the y intercepts of this equation. And remember, to find the x-intercept, we got to make the opposite 0. So the opposite of x is y, so we got to make the y 0. If we're looking for the y-intercept, we got to make the opposite 0, which means making the x 0. Now keep in mind, basically what this means here is, to make the y 0, we basically are getting rid of the y part, because anything times 0 is going to go away. So technically for the x-intercept, all we're left with is 8x equals negative 56. Okay, 8x equals negative 56. Now if I were trying to get the x solved for itself, I would divide both of these by 8, in which case the 8's cancel out on the left, leaving us with x is equal to negative 56 divided by 8 is a negative 7. And that would be my x-intercept. Now, once again, we could write that as a coordinate point, negative 7, 0, because the negative 7 is the x value that we found. 0 is the y that we plugged in. But this is the one we're going to probably want to type in our answer. All right? Now, in this one, since we're looking for the y-intercept, we got to make the x 0. Anything times 0 is 0, so that part goes away. And all we're left with is negative 7y is equal to negative 56. Okay? All right, get rid of a times negative 7 by dividing by negative 7. Negative 7's are going to go away, leaving us with just the y is equal to negative divided by a negative as a positive. 56 divided by 7 is 8, which would be our y-intercept. But just like we did over here for this one, if we wanted this to be a coordinate point, it would be 0, 8, because 0 is what we're plugging in for the x, and 8 was the y value that we just found. Okay? All right, this is more of a vocabulary question here. What is a vertical line slope equal, and what is horizontal line slope equal? Okay, so let's go ahead and define this real quick. Vertical. Vertical lines are lines that run straight up and down. Okay, so that means, that means that the slope is going to be undefined, because in order to have a slope, we are going to have to be able to move left and right. Okay, this graph never moves left and right. An example of what we would see here is when we get the slope to be equal to 2 divided by 0. Because keep in mind, what division basically means is how many times can the bottom number fit into the top number. So how many times can 0 fit into 2, or how many zeros can I put in the 2 until it's completely full? Well, since 0 takes up no space, I can put an infinite number of zeros into the 2 and it doesn't take up any space. And since I can't count to infinity, or we can't count to infinity, that's what makes the vertical line slopes undefined. Now, opposite of that, horizontal, okay? Horizontal lines, remember, they run side to side. They run like the x-axis, okay? Their slope is going to be 0. Okay, now an example of this one would be, let's go for the complete opposite here. Let's go for the slope equaling 0 over 2. Now this we can actually calculate because we're trying to figure out how many 2's fit into the number 0. So since there's no space for the 2's to go in, 0 2's are going to be able to fit into that space. So that's why we get 0 for the horizontal lines, okay? Horizontal lines running side to side have a slope of 0. Vertical lines running up and down have a slope of undefined. Okay, now we're down to the last question. Now, just because we're on question number 12 here, don't think that tomorrow's or that Friday's test will have 12 questions. There are a couple more questions sprinkled out through the test. But once again, if we're able to do the questions that we have on here, we should be just fine for that test. Here we want to write the equation in point-slope form. A little bit different. This is not slope-intercept anymore. Remember, this is the step before. This is the y minus y sub 1 equals m times the quantity x minus x sub 1 form, okay? Of a line that goes through point K for -6, or sorry, that goes through this point here for -6, and has a slope of 2 over 5. Now, some students do prefer to go ahead and list the information that we have here, and that's not a problem at all. So there's our information, okay? This is the point it needs to go through. This is the slope. And once again, we want to put it in point-slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, if we plug in our information, it's going to be y minus, this is our x1, y1 here. My y sub 1 is a -6 equals my slope, which is 2 over 5, times the quantity x minus my x sub 1, which is 4. Now, the only thing that we look to do here is we have minus and negative right here. So I maybe want to go ahead and change that to y plus 6 is equal to 2/5 times the quantity x minus 4, okay? Now, once again, this was asking us to put it in point-slope form, okay? If they asked for a slope-intercept, then we would continue it like a problem that we did before where we would distribute the slope through a set of parentheses and then bring the 6 over, okay? Remember, slope-intercept form is solved for y. Point-slope form should have y in a value equal to your slope with a set of parentheses, okay? We need to be using point-slope form formula for this one since that's what they illustrated for us in the instructions. Hopefully this helps you out with your understanding of the main topics of Chapter 2. Once again, this document will be given to you tomorrow. You work through it on your own. Then watch this video to hopefully show that you did problems correctly and show what problems you maybe need to study a little bit more. Make all necessary corrections and make sure that this paper, your study guide, before the test on Friday will find its way to the black bin, okay? Once again, though, as always, if you have any questions, send me an email.